Yeah, so suppose there is any curve, right? Suppose there is a parabola, and when the parabola reaches to infinite, right, then the straight line which seems like it's touching the parabola on infinite is called the asymptote. All right, are we clear?
Yes, sir.
So there can be two asymptote of this parabola, right? One is like can be this, one can be this. And they are straight lines. All right.
Yes, sir.
Okay. So there are two kind of hyperbolas. One is standard hyperbola. Other one is rectangular hyperbola. You can write that.
So what are the two types?
Standard hyperbola and rectangular hyperbola. All right. Standard
Yes, sir.
hyperbola has equation like this. Okay. And general rectangular hyperbola has equation like this. All right. Some people, you can write it as c square also, no issue.
What's the difference? Is it square root xy?
No. See, in standard hyperbola, the asymptotes are normal, right? There is no specific condition. But in rectangular hyperbola, the asymptotes make a right angle. They are perpendicular to each other. All right.
This is for rectangle?
No, not rectangle. Their asymptote make angle 90 degree perpendicular, and the name rectangular comes because in a rectangle all the angles are 90 degrees, right? So the name comes. This has nothing to do with rectangle. This has to do with asymptotes. The asymptote meet at perpendicular angles. All right.
Yes, sir.
All right. And this parabola, hyperbola has asymptotes as x equals to 0 and y equals to 0, x-axis and y-axis. This specific hyperbola. This kind of, if right, xy equals to 4, then this is a rectangular hyperbola which has asymptotes as x-axis and y-axis. This will be its graph. All right.
Yes, sir.
Okay. And in a standard hyperbola, if you do a equals to b, then you have equation x square minus y square equals to a square, right?
Yes, sir.
This is also a rectangular hyperbola. All right.
Okay, sir.
Okay. So I cleared till this, right?
Yes, sir.
Okay. In a standard hyperbola, please write this down. The asymptotes are y equals to plus minus b upon a x. This is the equation of asymptote. We just learned that the asymptote is a straight line. So this is the equation of straight line, right?
Yes, sir.
All right. So no issues here.
No, sir.
Okay. Parametric equation of hyperbola, you can write x as plus minus a cos ht, y as plus minus b sine ht. You don't need to write here sine ht. All right. All right. If you don't want to use hyperbolic functions, then you can use parametric equation as x equals to a sec t, y equals to b tan t. All right.
Yes, sir.
No issues.
No, sir.
If you want to use hyperbolic functions, then this is the answer. If you don't want to use that, then you can use this. So let's do a question. The hyperbola h has equations 9x square minus 4y square equals to 30. Sketch h b equations of asymptote creates parametric equations.
Yes, sir.
Do you want me to solve this?
No, sir.
Okay, please try. I'll give you a few minutes.
A equals to 2, B equals to 3,
A equals to 2, b equals to 3, right?
Y equals to plus minus 3 over 2x,
All right. So equations are y equals to 3 by 2x and y equals to minus 3 by 2x.
x
All right.
equals to plus minus 2 cos t, cos
Cos
ht,
h, yeah, cos ht, and y equals to
3 sin ht.
all right. So you can solve questions like this also.
Yes, sir.
Now there is a concept called not a concept, is a topic, eccentricity. We denote this as E. All right, eccentricity. All right, it's a ratio eccentricity is a specific ratio, and parabola, ellipses, and hyperbola all have eccentricities. All right. Ellipse has eccentricity greater than 0 but less than 1. Parabola has eccentricity as 1. Hyperbola has greater than 1. All right. Write this down. I'll explain what eccentricity is. First, learn the values. For ellipses, eccentricity is between 0 to 1. All right. Hello.
So what have you done in the middle?
Parabola eccentricity is equals to 1. And hyperbola eccentricity is greater than 1.
That is exponential, right?
No, just E, normal E. E for eccentricity. All right.
Yes.
The letter E. All right.
Yes, sir.
See, eccentricity is defined as
So for
the
the
ratio. Sorry.
middle one, it was written equals to
Yeah,
greater.
equals to 1. Parabola, this is implies just arrow. All right. E equals to 1.
And
And
for
for
hyperbola, it's greater.
yeah, E is greater than 1. All right. It's a ratio. Let me define it.
Yes, sir.
It's defined as the ratio between the distance between a specific point and a line. Suppose this is a point P, all right, and this is S, and this line is M, all right, or this line is a line, and this point is M. So I can find out the distance between this point and the line, right? PM, and I can find out PS, distance between 2 points, right?
Yes, sir.
So if I figure out PS upon PM, ratio between PS and PM, this is called eccentricity. All right. The ratio of distance between a specific point and the distance of a point from a specific line is called eccentricity. All right.
Yes, sir.
And this point is called focus. This line is called directrix. All right.
So what is the direct called? Direction.
Directrix. Direct, RIX. Directrix. The line is called directrix, and the point is called focus. All right. All right.
Yes, sir.
Okay. See, have you heard anything called locus? Do you know anything about this?
No, sir.
Okay. Locus is a collection of points. All right. See, if I draw a line, then it is a locus, because what is a line? It represents all the points that are on this line, right? So it is a
Yes, sir.
collection of points. If I draw a circle, then circle is not this area or this area. Circle is the points on this rounded line, right?
Yes, sir.
So any collection of objects, any collection of points is called locus, given or subscribed to a specific condition. All right. So in conic section, when you read parabola, ellipse, and hyperbola, the condition is applied to eccentricity. All right. Like the definition of parabola is the locus of all the points which are equidistant from a given point and a given line. if you want to write for clarity, you can write also the definition of parabola. How do we define a parabola? Its definition is locus of all the points which are equidistant from a specific point in a given line. The point is focus and the line is directrix. All right.
Which are equidistant
From a given point and a given line. All right.
Yes, sir.
See, now if I name this P and S and M, so in parabola, I just told you this is equidistance, right? PS equals to PM. So PS upon PM is 1. So the eccentricity is 1. That is why parabola has 1 as eccentricity. All right.
Yes, sir.
Okay. Now coming to ellipse. Give me 1 minute. All right. You wrote that down. Give me 1 minute. Yeah, for ellipse you can write down if you want. Can you tell me if PS upon PM is eccentricity and for ellipse this is less than 1, that means PM is greater, right?
Yes, sir.
So the definition is collection of all the points or locus of all the points, and the distance between the point is less than distance between the line. All right, and this line also is also called directives, and this is focus. So these three curves, parabola, hyperbola, and ellipse, are divided or categorized with respect to eccentricity. All right, the ratio. No
Yes, sir.
problem. Even the equations are found out like that only. So please write it down. If you have an equation
What
like
was
this,
the graph called? Like
the
this is a
graph,
graph, right?
yeah. See, the graph that we get is called ellipse. This is the collection of all the points. This is called ellipse. When you have eccentricity at 1, then you will get this graph, and this is called parabola. When you have eccentricity as greater than 1, then you get curve like this. Sorry, very wrong. Yeah, hyperbola. All right. All right.
Yes, sir.
Oh, okay. Now moving forward.
So what was
If
the
you have a
standard equation for parabola?
parabola, you this.
There's no plus minus.
No, there is no plus minus. You can write plus minus also, but not the
Where was this
no plus.
equation derived from? Or is
You
this a
want to?
general equation? No, I want to know
Oh,
from where. Is it from x square over a square?
I'm not getting actually. What are you? Where is this in book
Where is
or
this
what?
equation derived from?
Derived from? This is derived mm, with the help of the condition. This is not derived from anything. This is derived from the finding the locus. Do you have you ever found out the locus? Have they ever taught you like that in school or to find
No,
out the
sir.
locus of any point? No,
So
all right.
shouldn't x square equals to 4 be like x square equals to 4 by, not ay?
Yeah, you can write by constant, right? So no issue there. You can write by, you can write cy. I I have the habit of writing ay. All right, it's just a constant, right? It can be anything.
Yes.
All right, no issue.
No, sir.
Okay. So if you have a general equation of ellipse like this,
So did you wrote eccentricity for rectangular hyperbola, or is it
same,
not
it's
there?
the same. See, hyperbola eccentricity is greater than 1, right? Be it rectangular or general or anything, the
Yes, sir.
eccentricity will be greater than 1, right? Because in hyperbola eccentricity is greater than 1.
Yes.
All right,
So it's the same equation.
the same. uh,
Is greater than 1
yeah, is greater
for
than 1
rectangular hyperbola.
also. Yeah, because it is a hyperbola, right? Hyperbola is defined like that, which the curve which has eccentricity greater than 1 is called hyperbola. All right.
But this is rectangular, so
No, no,
it's not different.
any hyperbola, see, uh, dependent on eccentricity, the curves are divided on 3 parts. All right, one is parabola, one is ellipse, one is hyperbola. Now if you categorize hyperbola into 2, 3, 10 parts, it's your choice, right? But in with regards to eccentricity, it's only 1 divided in 1. It should be greater than 1. All right.
Yes, sir. Because
Yeah.
I was searching for it and it is telling me it's only 2.
No,
Like there's no greater or less, it's just equals to 2 for
e
rectangular.
equals to e equals to 2
Square root 2.
root 2. Yeah, it may be the case. It may be the case. I cannot say for sure. I haven't
Because since this is
remembered like.
same as parabola, it
No, no,
cannot
it's
have like,
not same. No, it's greater than 1, right? Root 2 is greater than 1.
yes, sir.
Yeah.
But
So
for
it
parabola,
satisfies.
it's like there's no value for e. For this one, it's just square root 2.
No, no. Parabola is e equals to 1. There is a value for parabola e equals to 1.
Well, yes.
All right. For parabola e equals to 1. For ellipse e is less than 1.
Mm, okay, sir.
All right.
Yes, sir.
Okay. Let's move forward. If you have a general equation of ellipse, and here a, suppose a is greater than b. All right. See, if you have a is greater than b, then the ellipse looks like this. And if b is greater than a, then it will look like this. All right.
So can you write the letters beside them?
Oh, here a is greater than b, here b is greater than
Yes,
a.
sir.
All right. And to find out or solve any questions for a is greater than b, we write b square as a square 1 minus e square. All right. This is the first equation that you'll be using. The foci, there are two focuses for ellipse and hyperbola. The foci are at, the coordinates are this, e comma 0. All right. The equation of directives,
So what is number 1?
b square equals to a square into 1 minus e square. They'll give you the value of e. All right.
Yes, sir.
For different ellipses, they'll give you different values. All right. The foci are at plus minus a comma 0. The equation of directives
So
are,
in real life situations, where are these used? These graphs and these
uh,
formulas?
what what do you want to be in future?
Well, I'm doing robotics engineering.
Oh, robots. Great. That's great. So, do you think you are going to use these things in robotics or not?
Yes, that's why I have
Yeah.
a chapter on this.
Yeah, definitely. So that is where you are going to real life you see. Suppose you are making a robot. What was the Boston Robotics, right? Now the leading company in the world in robotics. Its name is Boston Robotics. I think I may be wrong. You you can check out their page on YouTube also. They are making amazing robots, right? Amazingly like great robots. So suppose they have to make a hand or a leg, the foot. Suppose you propose that if the foot is elliptical shape, then it is more balanced. But suppose your colleague says no, we should make it circular. Now if you are going to use an ellipse as the foot, the shape of foot, then you should know, right, where the force is arranged, how the inertia is managed, right, all that. And for that to happen, you need to know all these things, where the focal point of ellipse is, where it is concentrated, right?
Yes,
And
and this focal point is also in physics, right?
yes. See, center of mass. Have you ever uh,
Yes, sir.
read that? Yeah. So center of what is center of mass? All the mass is
All
concentrated
the
in a
mass.
single point. Yeah, right.
Yes, sir.
And why do we use that? Because to calculate many things, we need to take one single point, right? To see where
Yes,
the force is applied. So all things are connected. You are in a great field. Robotics has a great application in near future also. Near future and future is robotics only. So please focus on maths, physics in a wholesome way. Don't look at these chapters individually. All right.
yes, sir.
Okay. So to find B or A or E, they'll give you two values. You have to find the third value. In the foci, you can find by plus minus AE, comma 0. Equation of directrix are x equals to plus minus A by E. All right. Where is
Yes,
greater
sir.
than B? You have to keep that in mind. All right. And where B is greater than A, the things change.
I was writing that.
Yeah. You will write this as A square equals to B square into 1 minus A square. Second is the foci 0 comma plus minus BE. Third equation of directrix would be y equals to plus minus B upon E. All right. When B is greater than A, you need to keep that in mind. Ellipses, you have to check first A is greater than B or B is greater than A. All right.
Yes, sir.
Then you will have to find all these things. There are separate formulas for both. All right. You can
What is
check
the
on
last
this
one?
directrix. Equation of directrix is y equals to plus minus B upon E. All right.
Yes, sir. Can you go back?
Okay. Here.
What is written in the end?
Equation of directrix are x equals to plus minus A upon E, and where B is greater than A, this is B upon E, and this is y equals to. All right.
So, yes, sir.
Let's do one question, then you will be absolutely
Can I see
clear.
the equation for the B part?
Yeah. So here.
Yes, sir.
Let's solve one question. You have a question x square upon 9 plus y square upon 4 equals to 1. What is the value of A here? A is 3, right? And B is 2.
Yes, sir.
So A is greater than B. So we are going to use the first three formulas, right?
Yes, sir.
Okay. So the foci will be plus minus AE comma 0, right? So this is, first let's find out E, the value of E. How we are going to find out is, we're going to use the formula B square equals to A square into 1 minus E, right?
This is the first step, right? That's the
Yeah, first
second
form.
step. The,
See,
the one on the
first
left.
step, yeah, this is the second step. First step is to find E. All right, this is E square, sorry. Yeah, first step is to find E.
Yes, sir.
Because, yeah, so you are going to use this formula. All right, the value of B is 2, so 4. This is 9. 1 minus E square. So 1 minus E square is 4 upon 9. So E square is 1 minus 4 upon 9. So this is 5 upon 9. So the value of A is under root 5 upon 3. All right.
Yes, sir.
No problem.
Yes, sir.
So the value of the coordinates of foci will be plus minus A 3 into E root 5 upon 3 comma 0. So this is plus minus root 5 comma 0. All right.
So that is plus minus, right, on the front?
Yeah, plus minus. One is root 5 comma 0, other one is minus root 5 comma 0.
Because it was looking like an I.
No, this is plus minus. All right, plus minus. All right.
Yes,
And the
sir.
directives, equation
Yes.
of directives, third step, direction of equation of directives would be plus minus A by E comma 0, right? So
Yes.
plus minus 3 upon root 5 upon 3 comma 0. So sorry, this is not, what am I writing? This is x equals to plus minus A upon E, right? X equals to plus minus 3 upon root 5 upon 3. So this is x equals to 9 upon root 5 plus minus. So one equation will be x equals to 9 upon root 5. Other would be x equals to minus 9 upon root 5. This is your complete answer. All right.
So what was the final answer?
These
Can you
three. You have
circle
to
it?
find all the parts. This is equation of directives. This is equation of foci. This is the value of E. All right. The first step is to find A, B, and E, all three. All right, because you may need to use that, right?
Yes.
You do one question. I'll give you. Did you write it down completely?
Yes, sir.
Okay. Do one question. X square upon 16 plus y square upon 25 equals to 1. I'll give you a few minutes.
equals to 3 or 5.
3 or 5?
3 over 5.
Okay, 3 over 5. All right.
Foci is 0 plus minus 3.
0 plus minus 3. All right.
And directory is y equals to plus minus 25 over 3.
Absolutely right. So I hope we are clear with this. No issue.
I had a question on the equation. Like, what if there is 2 instead of 1 in front of it? Like, all
Oh,
of this equals
this
to 2. Yes. I think I remember one in my previous
just
classes.
just divide 2 on both sides. See, this will become 32 plus y square upon 50 equals to 1. Very easy. But they will not be giving you questions like this because the calculation here will be very tough, right? Here you are
Yes, sir.
taking under root and you are getting very good answers. All right. If
Yes,
you
sir.
have any number on this side, just divide them. All right.
Yes, sir.
Oh, so let's move forward. In a hyperbola, you can write hyperbola. The standard equation, as we saw, this is the standard equation, right?
Yes, sir.
Here we'll use the formula b square equals to a square minus 1 first. The second one is foci. The third one is directives. And in hyperbola, it doesn't matter if b is greater than a or a is greater than b. You just use these three formulas. All right.
Yes, sir.
No doubts.
No, sir.
Okay. So do you want me to solve a question from this, or we shall move forward, because it's the almost same concept, right?
Yes,
Okay. So let's move forward.
sir. We can move forward.
Tangents. Yeah, tangents and normal. See, in tangents and normals, we already did that in the differentiation chapter, right?
Yes. The
Do you remember?
equations.
Yeah, you need to find the equations of tangents and normal. Very easy. You can find out, right? We
It is
solve
same,
questions
right?
like,
Y equals to mx plus c.
yeah, y equals to mx plus c. You find slope by finding dy by dx, right? And the slope of normal is d minus dx upon dy, just reverse and negative, right?
It is differentiation here as well.
Yeah. It is differentiation here as well.
Okay. Nothing
All
new.
right. No, nothing new. If you have to remember, then there are basic
Because we did the differentiation
equations.
chapter. That's why.
Yeah. We read that chapter because we are going to use that in mathematics, right?
Yes, sir.
But if you want what is new here, then you can check page number. I don't believe in memorization, but if you really want, then page number 30 of the book. They have written the basic equations of ellipse, both tangent and normal, right? So you can directly use that also in short mark questions. All right. All right.
Yes, sir.
Okay. And always use parametric equations in this. If you have take any point like that, then use the parametric a cos t and y equals to b sin t. Right? Don't take just x and y. Take like this.
Yes, sir.
All right. So we can move forward with this also. Now the thing that I was saying, loci, the last thing of this chapter. Okay. loci. See, loci is the collection of the points that I mentioned, right? Mentioned. We have to find. See, if I give you a condition about a point moving in space, right? If I tell you there is a point which moves in a constant distance from another point, if A and B, A moves in such a way that it is always 5 meter far from B, then how will it move?
Is this like a circle? And that's the radius?
Exactly. Yeah, exactly like a circle, right? And
Yes,
this is
sir.
the radius. This A can move in this path only. If it deviates from this path, then this condition will not be satisfied, right?
Yes, sir.
So if I ask to find the loci of this point A, and I give you a condition that it moves 5 meters away from B always, then the equation you will get is a circle, right?
Yes, sir.
And that is the locus of A also. It's very easy.
Locus is like perimeter.
No, no, not perimeter, the equation, the path the point follows in under a given condition. All right. The path followed by a point given in a given condition is called locus. All right.
Okay, sir.
No issue.
No, sir.
Okay. Now, if I let's calculate how. Let me tell you how to get the equation. Suppose the same condition I have. If I tell you find the locus of all the points moving 3 centimeters away from 2, 3. All right. The first step, you write down the question.
Yes, sir.
Okay. The first step is to assume the point. Suppose my point is x comma y. This is 2, 3. All right. Suppose my point is x comma y. And in the cases of ellipses and hyperbola, take the parametric form, right? There is no parabola or hyperbola mentioned here, so I am not taking parametric. I am just taking x and y. All right.
Yes, sir.
So now I'm going to apply the condition here. Distance between them is always 3 centimeters. So I'll write x minus 2 whole square plus y minus 3 whole square under root is 3, right?
Yes.
So x minus 2 whole square plus y minus 3 whole square equals to 9. This is the equation of a circle. This is the coordinates of center, and this is the r square, radius square. All right. This
Yes,
is the
sir.
locus. It's very easy. All right.
Yes, sir.
We are clear.
Yes, sir.
Just whenever they mention parabola or ellipse or hyperbola, take the parametric equations. All right. If you
Yes, sir.
take normal points, then it will be an issue. Let's solve one or two more questions.
So what is the difference in the equations of hyperbola and eclipse with tangent and normal?
You can see open page number 30. I told you, right? I don't believe in memorization. If you want to memorize, then it's okay. But I don't believe, because if in exam
In the
you
examples,
forget.
I'm seeing it like y minus the a and then x minus b. But on the hyperbola side, it's like y equals to mx plus c or minus c.
No. See,
Now you
where
can
I
see
don't.
in on page 30 and on page 33. Like, so is the equation same for this one?
No. They are saying, see, any tangent, no matter what, in a circle, parabola, hyperbola, ellipse, or anything, any tangent is a straight line, right?
Yes, sir.
So it will always be like this, no matter what, because this is the equation of straight line.
Yes, sir.
They are saying that in page number 30, show that the condition for y equals to mx plus c to a tangent to the ellipse is b square plus a square m square equals to c square. They are saying that instead of taking like this, or the value of c can be found out like this. For any tangent, this is true for ellipse. They are asking you to prove this. All right.
Yes, sir.
They are saying that, nothing else. And if you really want to learn the formulas, then on page number 30, they have given you specific formulas of tangents and normals of ellipse.
And this is same for the hyperbolas as well, right?
No. Hyperbolas have different formulas on page number 34. All right.
Yes, sir.
So please try questions. And tomorrow is our last class, right?
Yes, sir.
Do you want to solve doubts or do the first chapter? I'll give you a brief. You told me it is finished, but if you want, I can give you a brief in tomorrow's class.
I'll send you some past papers. We can do that. There are only two
Okay.
past papers.
Okay. We can solve that also. Please send me today if you can, or tomorrow, because we'll have to fix the time also, right?
Yes, sir.
Okay. Then please do all the questions. We'll meet you in the next class.
We'll
Okay.
probably not have a class tomorrow because I have classes all day.
Okay. Then day after tomorrow.
Yes, sir.
Okay. Then bye. Complete the
Do I
homework. All
send
right.
you the mark sheet as well? So you
Yeah, you
can see
can.
the
Yeah, you can
answers.
send. All right.
Okay.
Send me the mark sheet as well as the questions. All right.
Yes, sir.
Okay. Bye.
Okay, sir. Thank you, sir. Bye.
Yeah.